Hello, Yawning Angel back again with another AMOS video, and in this video I'm going to be looking at kicking off development for Space Race for AMOS version 2. So this follows on from my previous video where I made a version of the arcade game Space Race in AMOS specifically. There's a link to that video up here if you've not already seen it. And that was quite a successful little project, but I want to advance things further for this video. Specifically in this video, I'm going to be looking to make use of AMOS's built-in animation language, AMAL, in order to develop this game. But wait, I hear you ask, what actually is AMAL, Yawning Angel? And how does it work? Well, so AMAL is the animation language for AMOS, and if you have the AMOS Pro manual, you can find out all about it in section 070601. AMAL is a language which sits within AMOS and enables the movement and animation of bobs and sprites, and sometimes screens. It has its own syntax and its own definitions. The most amazing thing about AMAL is that the AMAL code you write inside your AMOS program is actually compiled before the AMOS program runs. So effectively, AMAL instructions are running in machine code, so they're a lot faster and a lot more efficient and reduce the load on the AMOS code itself. Witchcraft. So with that load reduction, it makes it ideal for game creations because you can animate your graphics, put your own twist and look and feel to them without overloading the core AMOS code. This is fantastic. But of course, we'll cover this in more detail later when we start looking at the code. So I have touched on AMAL before, back in some previous tutorial videos that I've done, probably around bobs and sprites. But in this video, I want to explore AMAL in more depth and in greater detail, and indeed see if it is actually the right tool for the job and helps me to get what I'm trying to achieve out of this game. Speaking of which, so in case you don't know, or you've not watched the previous video, the concept for this game is quite simple. There are two spaceships positioned at the bottom of the screen. Players, either one player or two players, can control each one of those ships and move them vertically up and down the screen. There'll be a bank of meteors appearing on the right and the left-hand side of the screen, and these meteors will move across the screen repeatedly, and players have to move their ships up the screen in order to score points while avoiding the meteors. Oh, and all this is done against a timer as well. So for this video, I'm only going to concentrate on a few parts. We're not going to do the whole game creation in it because that would make for an infeasibly long and boring video. So for this video, I'm going to concentrate on getting the new graphics for the spaceship on the screen, the new graphics for the meteors on the screen, and enable joystick control on the spaceship, as well as animating the graphics. And I'm going to do all of this in AMAL. So without further ado, and you know how this works, let's grab a brew and dive on into some code. Okay, here we are in front of the code, cup of tea in hand. This time it's in the Retro Collective mug. The Retro Collective, Neil and the gang. Cheers, guys. Yeah, that's not bad. Not bad this morning. Right. So what I want to do then is take you through the code. But before I do that, I want to go through the object editor and just show you the new graphics that I have created for this version of Space Race for AMOS version 2. Don't forget that the code and all relevant files will be available to download for free from my website. There'll be a link down below and stuff, so don't worry about that. So you can have a look at the code and amend and change and play around with it to your heart's content. Right, so let's start off then and have a look at the new graphics. Now, regular viewers of this channel will know that I cannot draw for toffee. I am not a graphics artist, but I've given it a good go. So what I've done here, I've created a new design for the spaceship. And because there's going to be two spaceships for two players, this one is number 1. And if we scroll down, I've got spaceship number 2 here. Both exactly the same, save for the numbers on them. And you'll notice, the eagle-eyed amongst you will notice that I've got different variations of each ship. Also, if we scroll down, I've got a new meteorite. Look at that. Class, eh? Like I said, I can't draw. But I've given it a stab. We've got some variations on that as well because we're going to be animating these bobs, and these are bobs. We're going to be animating these using AMAL. So if I quickly jump into the animator, and let me just show you what these are going to look like. So if I select all of these different variations, so ship 4, 5, 6, I think that's it, yep. And if I bring the animation speed down, if you look down here, you'll see that ship animation. We've got the engines, the exhaust, sorry, the flames from the back of the engine there, and some lights flicking on the ship as well. So this is the player 1 ship. The player 2 ship animates exactly the same way. If I get rid of these, let's have a look at the meteorites. Seriously, you're going to be amazed when you see these. Bing, 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 bing. There we go. And look at that. It's, now I know it looks like it's just kind of jumping, but it's not. It is actually rotating. It is a fully rotating meteorite. Like I said, I can't draw. This is as good as it gets. So the animation speed, I kind of set to 12, and take a note of that number because we'll be using that number in the program code when we do the AMAL animation. So there we go. That is, well, those are the new graphics, really. I'm quite pleased with them. So what I am going to do is very quickly show you what the old graphics look like for those who haven't seen the previous video. So we'll take a quick break and have a look at those now. Right, so I've quickly loaded up the previous program and the ABK file for that. And it's interesting from my perspective to see how all these have evolved. So from my original concept of what the ship would be, and how I kind of played around with it, and then we got to this version of the ship. And I think you'll agree that my new graphics, I would like to think are an improvement over this, but I will leave you to be the judge of that. But yeah, so I'm quite pleased with that. And I think the meteors, yeah, they were just these kind of dots that moved across the screen. So now we've actually got something a bit more full-bodied that actually looks like a meteorite. So with that said, that's having a quick look at the graphics, the new compared to the old. And now let's dive into the 3 programs that I have written to start to get this process moving. And we're going to do that next. Okay, into the code, but first tea. Oh, that is so good this morning. I'm going to have to get another one later. Right, so what I've done, I'm building this process up, a kind of function at a time. So I've started with the first program, and this is really the base concept. So I've got some comments in here, and it says this is the base concept with no AMAL. What this is going to do, this is going to set up the screen. It's going to load the bobs, it's going to position the bobs, and that'll be one ship and one meteor, and then give basic joystick control. This is all stuff that I've covered in previous videos, so I'm not going to go through the mechanics here. Just a quick whistle-stop tour through the program and show you what it does. But this is our starting point, okay? So here we go then, we've got our screen set up. It's a 320 by 200, 16 color low-res screen. We load our ABK file with our bobs in it that you've just seen. We get our bob palette, we define some variables, so our ship X and Y coordinates and our meteor X and Y coordinates. And then we've got a do loop, and we position our bob on the screen, our spaceship bob on the screen, we position our meteor bob on the screen. And then we've got our joystick control, basic stuff. Joystick up, joystick down. I've put left and right in here as well because I just wanted to test some stuff out. Fire button will end the program. We've got our wait VBL in there. We loop through this and we end the program. It's bread and butter bob animation stuff, really, or bob positioning on the screen stuff and animating via the joystick. So let me press F1 and let's just run the code. And literally that's all you've got on the screen, a static meteor and the spaceship. But if I grab a joystick and I move, my spaceship moves around the screen. You know, there's no collision detection or anything. This is basic, just to prove that it works. So this is how we would do it in normal AMOS if we were not using AMAL. So with this said, I'd like to think that this program gives us a starting point to see where we've come from and where we're going to get to. So you'll be able to see each stage develop as we move through the AMAL process. So if I press fire to end that, that is really it. That's the first program. Now we'll take a look at the second program where I start to introduce the AMAL code. Right, so this is the second program, and this is where we're going to start to introduce AMAL to bring in the functionality for animating the bobs. So this program, basically, as I say here, this advances the base concept by introducing simple AMAL. So what we do, we set up the screen, we load our bobs as normal. Then we create channels. Ooh, channels, Yawning Angel. What's all that about? Well, channels, I'll explain those in a bit. We define our AMAL for the ship and the meteor. We have the AMAL to animate the ship and the meteor. We position our bobs. Basic joystick control on the ship has been removed. And that is because we'll be looking at that in the next program. Joystick fire ends the program. So let's go through the code then. So we're going to open the screen. We're going to load our bobs, do our bob palette, do our double buffer, make Mars. Then there's a comment in here. Set up define channels for AMAL. So channels, Yawning Angel, and AMAL. What's all this about? So think of it as your AMAL code that you write sits in a channel, and that channel is executed as for the AMAL code to run. Now AMOS allows you to have up to 63 channels, so you can have effectively 63 AMAL programs that run. There are different channels that handle different things, especially when it comes to screen interrupts, and we'll look at that in a future video. But for now, we're just going to use a couple of channels, one channel for our spaceship and one channel for our meteor. So I'm going to stick that code in now, and basically the channel code is really straightforward, and all it is this. So we do channel 0. Yes, I am reading the code off to my right here. So channel 0 will be to Bob 1. So I'm going to put a rem statement in there. So this is the ship channel. So what this is saying, Bob 1, whatever we define Bob 1 as, this is going to be running in channel 0. This will kind of make more sense when we get into the AMAL code. But for now, just think of it as we're creating space, we're allocating an environment almost for that AMAL to run in. So this is our channel and this is what it's for. Then we're going to have channel 1 to Bob 2. And this will be this will be the meteor channel. So there we go. We've got two channels defined, 0 and 1. 0 and 1, if that makes sense. You follow me, yep. So then what we do, we've got these ship variables. We may not need them, the ship and the meteor variables. Then I've got a big chunk of comment in here for explaining the AMAL code. So what we're going to do is define a variable string to hold the AMAL instruction code for the ship. Now, because AMOS will run AMOS commands, but the AMAL has to be kind of embedded in a string, and it's that string which is executed in the channel. Yeah, stick with me on this. So basically the breakdown is we're going to set the first bob using the bob command. Then we're going to create a string with the AMAL code in it. In this case, animate 0. So the command will be animate, and that's what will animate our frames for that spaceship bob. And I think I've got three bobs that make up the total animation for the ship. So the command will be animate 0. And this will, 0 actually loops the animation sequence indefinitely. So any other number we use in here will give it a number of times it will do the animation. So if you set 5, it will only animate for 5 times, 10 times, etc. But we want the animation to keep going, so it's animate 0. Then we give it the bob number that we want and a delay of 12. Now that number 12 you would have seen in the animator when I was in the object editor. That's the number that I've chosen to use. And then bob number 5 for a delay of 12, bob number 6 for a delay of 12. And I've said here 12 was the number derived from testing animation in the object editor. And then we're going to issue the command by running it in channel 0 and sending the AMAL code string to that channel. But the code will not actually run until we turn AMAL on. And this is a very important point. You can switch AMAL on and off in your program. You can pause it. You can do whatever you like, and it will adhere to those instructions. Very useful for conditional animations and the like. So let's get going. So for starters, I've just dumped the ship on the screen. Actually, if I run this code, there you go. That's pretty much left over from program 1. I've got the meteor on the screen and I've got the ship. No animation, nothing's happening. There is no joystick control. Right, let's come out there. So what I'm going to do next is, let's find the code. So I'm going to define a string, and I'm going to call that string ship string. And that is going to equal, now this is where I start to build up my AMAL instruction. Now, because AMAL is akin to machine code, it doesn't need the full word for the instruction. The first letter will do. So you can pad out the rest of the instruction with anything that makes sense to you. So I want to animate, so the AMAL instruction is A for animate. So I could just type A and then get my animation string up and running. But I've just chosen to call it anim. So I've gone anim 0. So this will loop the animation. And then what we do, comma, and then in brackets, we put the bob number and the delay in there. So I'm going with, so bob 4 for 12, yep, and then bob 5 for 12, and then bob 6 for 12, semicolon. So the semicolon in AMAL is exactly the same as a full colon in AMOS. It does exactly the same thing. So that's my string defined with my AMAL instruction, my AMAL animation instruction in it. Next, I need to do AMAL channel 0 ship string. So what this is saying, for channel 0, you're going to use that string, ship string. That is your instruction. Well, that is your AMAL program. And then, well, actually, I'll tell you what I'm going to do. I'm going to run this now. No animation, because we haven't turned AMAL on. And that's what we're going to do next. So now if I come out there, and my next instruction will be AMAL on 0. This turns on channel 0, and this will get our ship animating. Are you ready for the magic? Look at that. The ship is animating. It's just sitting there, its engines are ticking over, its little indicator lights are blinking, but we have the animation working. This is good news. So that is really it. It's all this is really using is that definition of the AMAL instruction in the string, assigning the string to the channel, in this case channel 0, and then it's turning on channel 0 to get that animation working. Be aware when you are writing your code like this and you've come out of your program, your AMOS program is no longer running, but the AMAL code will still be running in the background unless you've turned it off. So if I come down to the code here where I've got my fire button, when I press that, it's turning the AMAL off and then it's ending the program. If it just ends the program, it's going to leave your AMAL running away. And you will notice your Amiga start to get warmer because it's just running animation, graphic animation in the background, and you cannot see it. Trust me, it happens. Right, so the next thing, let me come back. The next thing to do will be to do the same for the meteor. Let me just tidy this code up. So I'm going to do the same code for the meteor. So let's get that meteor done then. So I've got a new string now called met string, and that is going to be, I'm going to build up exactly the same animation for that. So anim, the AMAL instruction, so I could just do this, A0. It always has to be a capital letter for the start of your instruction. But that is pretty much unreadable, so that's why I put in anim. AMAL will ignore the N and the I and the M, so don't worry about that. So you can just put in a word that works for you, but the first letter has to be in uppercase and it has to be the right letter for the instruction. All of this is detailed in the AMOS manual, section 70601. Right, so for this meteor, let me just take my code. So it's going to be 10. I've changed the cycle of this to 18 for reasons basically. Don't forget, I've got 4 bobs that make up the animation of the meteor. So that's 11, 12, 18, and then I've got 13, 18, semicolon. There we go. So that's our meteor string. Then we issue the instruction AMAL channel 1, met string. Okay, so that's taken that met string AMAL program and it's put it into channel 1. So then I'm going to do AMAL on 1. Okay, and if I save that, if I run this program now, you should see an animating meteor. Look at that, a little meteor just turning around, just cycling through. It's happy, it's there in the darkness of space, just cycling through. Now, you're going to say, joystick control, Yawning Angel, why can't you move the ship anymore? I press fire and I can end all of that. In my main loop, so I've commented out a load of code here because it's no longer needed because AMAL is handling it. So the positioning of the Bob ship, that's commented out, the meteor is commented out, but notice the joystick control is still in here, but it's not working anymore because we're not controlling the ship in the do loop anymore. We're doing the animation for the ship outside of the do loop. And what we're going to do in the next program is take the joystick control and put it into AMAL, because AMAL will allow us to have joystick control for an object as well, which is pretty cool. So that is it for the second program. Let's take a look at the third program, do the joystick control and advance this code on. Right, program 3. Let's get myself in focus. Yes, program the third. So I want to show you, I mentioned earlier that if you don't turn AMAL off when you come out of a program, it just keeps the animations running. Let me show you that. This is actually the third program. We'll go through the comments in a while, but I can run this because it's got the animated meteor and the animated ship. So they're going there quite happily. If I do Control C to end the AMOS program, and the program has ended, which is fine. So I can now go into the code. There it is, it's all beautiful. So the program is no longer running, but I didn't come out of the program by using the fire button where it would actually turn AMAL off. So I haven't issued the AMAL off instruction yet. If I now press escape, which will take me into direct mode, look at the screen. Look at the meteor is moving, the spaceship is animating, AMAL is still running, even though the AMOS program is not. And now if I, from direct on the command line here, if I do AMAL off, that turns off AMAL and you notice the animations have stopped. Be aware of that, because if it keeps running, things will get warm on your Amiga. Ask me how I know. I was sitting here one night, so I've got an Intellivision AGA card, HDMI card fitted in my Amiga. And the card was getting really hot one night when I was doing all this code, getting hotter than it does when it's actually running proper games. And I couldn't understand why. And it's because AMAL was just ticking along in the back. Every time I ran a program, it was just more AMAL, more animations. So be aware of that. Anyway, right, enough of my woes. Let's get and have a look at this, the comments in here and what the third program is actually doing. So we advanced the base concept and we're trying to get to grips with joystick control of AMAL objects here. So we do the usual, set up the screen, load the bobs, create the channels, define the AMAL for the ship and the meteor. We've already done that in program 2. AMAL to animate the ship, AMAL for joystick control on the ship only. And position the ship and the meteor, joystick fire to end the program. So it's this joystick bit that we're going to be doing here. Now, what I have got in this program, commented out here, is some dirty joystick test code. So this actually came straight out of the AMOS Pro manual. And what I'm going to do is just uncomment that, and I'm going to get hold of a joystick. I've got so many cables on my desk. Right, so a joystick. So here's one I created earlier, as it were. So let's run this. And what this does is I'm just getting this in shot. So as I move the joystick, you'll notice the numbers change on the screen. So I go left, it's the number on the right-hand side we're looking at here. If I go left, it's number 4, right, it's number 8, down, it's number 2, up, it's number 1. So, and as we go, obviously diagonally, we've got different values here, but essentially it's just giving us a numeric value on what the joystick instruction is returning, okay? And we need that number for AMAL, which is why I've left this code in this program commented out. So let me put that back. And let me come out of here. Right, so we'll comment this out again because I already know the values now. So we do our usual bob palette, mask, blah, 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 defined our channels. These values here, eventually these will go, but I've left them in for now. Right, so we do the animation. So I've got all of that set up. So now we need to set up and handle the joystick control. So can I suggest you make sure you're sitting comfortably for this because things starting to get real now. So the instruction for this can be a little bit long-winded, but let's get on with it anyway. So we've done our ship. So now we've got ship string, okay, ship dollar. That's got our animation in it. Now we've got our semicolon at the end, which means we can now add another instruction to that string. We can start to continue to build our AMAL program. So what I'm going to do then is we will have ship dollar equals ship dollar plus, because we're adding to the string. Okay, so you've taken an existing string and we're going to add new values to that string. And this is ship string plus, and then I'm going to do begin. Begin. What yawning angel is going on here? So let me explain this. Ship dollar already contains our animation command. Then we have a semicolon. Then we're going to add begin. And begin is a label. You can have labels in AMAL. So you will jump to different labels within the program. Like we do in AMOS with our procedures, in AMAL you can have jumps to labels and the code within that label will execute. So I'm creating a new label called begin. And the code here is very, very basic, so stick with me. Right, so in the next instruction, ship dollar equals ship dollar plus, and then we're going to do if J1 ampersand 4, then jump L, semicolon. Now you're thinking, what is going on here? Okay, so let me explain this. What this instruction is saying that if we've moved the joystick, so joystick 1 has returned a value of 4, as you saw earlier when I ran that joystick code, as I moved the joystick, it gave a different value. If we've moved the position of the joystick to the left, which is number 4, then we're going to jump out of this code and we're going to go to label L. We'll get to label L in a minute. So that's all I've done there. So now I need to do the same instruction for if we go right, if we go up, and if we go down. So ship dollar equals ship dollar. I wish I'd called this something else. Plus if J1 ampersand 8, then jump R. Okay, so I need to do this for up and down as well. So ship dollar equals ship dollar plus if J1 ampersand 2, then jump U, should be up. Oh, I made a mistake. This has got to be capital letters, don't forget. Let me tell you this, if you make a mistake in your AMAL code and you've got a massive chunk of AMAL code, it will only throw the error on the AMAL execution line, not the line within the AMAL code where the fault is. Bear that in mind. So kind of very machine code, I guess. Ship dollar equals ship dollar plus if, J1 ampersand 1, then jump D. Right, and then what I'm going to do, because I need this code to loop. Okay, there's no do loop in AMAL, so we need to do this. Ship dollar equals ship dollar plus jump begin. See what's happening here? I've created a label called begin, and then when I get to the end of that label, I tell the code to jump back to it. So it's constantly cycling through this lot of code here. It's checking that joystick all the time. Good news. Now what I need to do is now do the labels for L, R, U, and D. Wow, are you still with me? Keep hanging on, it's worth it in the end. So let's come down, let me just tidy this code up. So now what I need to do is to define the code and instructions for the labels, basically for the joystick labels. So now what we're going to do, ship dollar equals ship dollar plus. So we have our label for left, L, colon, move, -10, comma 0, comma 10. Semicolon, jump, begin. Space, semicolon. Right, there's a lot to get your head around here. What this is saying, we are now defining our label L, because if we move our joystick left, we jump to L, okay? Come down, here's L, and the L label has the code in it to move -10 pixels to the left. This is a basic move command within AMOS, so just -10 to the left. We're not moving any other direction. So we then, once we've done our move, we then jump back to begin. So it's almost as if you imagine this like a procedure. We're in the procedure, we do the procedure code, we come out of the procedure and then we go back to it. So what we've done here is this label is when we've done our move, we jump out of L and we go back to begin, where it continues to scan for the joystick instructions, basically. So now I need to do the other label. So ship string equals ship string plus R. So this is our label for right, and that will be move, and that is 10, 0, 10, jump, begin. Okay, still with me? So we're saying here, if in our begin loop, if the joystick is detected that it's moved right, we jump to label R, and that move instruction will move our ship to the right. And then once we've done our move, we jump back to begin. Yeah, it's heady, isn't it? There's a lot to take on here. So let's do the next one. Ship string plus. Right, and the next one is up, colon, move, 0, 10, 10, semicolon, jump, begin. Ooh. So, no, don't forget, you need to make sure your capital letters are in where they need to be, because if you don't have them, AMAL will not function. Right, that's that line. So finally then, ship dollar equals ship dollar plus D and move, and this one has to be 0, -10, 10. Is that a semicolon? Yes, semicolon. Just double checking. Jump, begin. Wow, so there we go. So if we notice in our begin label, we've got our jump commands will go to L, R, U, and D, and now I've defined them down here, L, R, U, and D. Okay, that's that. Now with that defined, guess what I need to do? Well, the command's already here. AMAL to channel 0, ship string. For our second program, our ship string only had about one instruction in it. Now it's got a chunk of stuff in it. But that's valid. That's how AMAL works. You load all your commands into that string. You fire the string at the channel. The channel executes when you turn the channel on. We've got it there. Turn AMAL on 0 and we should be good. Right. Let's save that and we will test the code out and see if this actually works. Are you ready? Okay, I've got my joystick. So here we go. We've got our bobs on the screen. There's our meteor spinning away. Spaceship there, engines revving, ready to go. So let me get the joystick in camera. Push up. Oh yes, look at that. Down, it's going down. Left, right, check it out. We've got movement. The ship is responding to joystick control and all of this is happening in AMAL. Yes, really, Yawning Angel, it is. Check it out. Obviously, you've got no collision detection at the moment. That will come in a future video. But we've got joystick control. I've got no diagonal control because I haven't actually coded that in. So I've only got left, right, up and down. But that functionality is actually working. So let's press fire to come out of that because you might be thinking, well, Yawning Angel, really, have you still got your AMOS code to handle the joystick in the program? Well, no, I don't, because in my main program loop, all I've got now is I'm just checking for the fire button. So if fire button is pressed, turn AMAL off, end the program. That's it. All other joystick commands are happening up here. Defined my main, I suppose the begin is like your main loop within AMAL now. I've defined that. I break out to the relevant labels if I move left, right, up and down. Excuse me. I just keep looping through that. As soon as I move the joystick, it branches out, goes to the relevant label, issues that instruction, then goes back to the main loop again, or the begin chunk of code. And then, the AMAL code is executed there in channel 0. One thing I did want to say is this instruction here, the J1, this is effectively using a code which is based on the joy command within AMOS. So this joy1 here is an AMOS command. AMAL is using the underlying code for that effectively. So it detects, what value J1 is returning. When you move the joystick 1, whenever I move it, it's just displaying that. Ooh, interrupted there. It just, takes that value and acts on it. So like you saw, when I had that code uncommented and I was moving the joystick, it was showing me my left, right, and up and down, whatever those numeric values were. And those are the values which I've keyed in to here. Does that make sense? Have a play with it, see how you get on. So effectively then, what we've got here is there's 3 programs. We've got the base program where we've looked at the new graphics and how we would do this in AMOS. And then we've slowly introduced AMAL. So the second program gave us our animating of the bobs, and our third program has got the animation of the bobs and of course the joystick control in there for the spaceship. Coming up in a future video, I'm going to be looking at moving the meteor across the screen and getting some collision detection in there as well. If you've got any thoughts or comments on that, please drop them into the comments down below for this video. But as far as I'm concerned, that is job done in terms of the code for this video. This is where I wanted to get to. So all in all, happy days. And that is it for this video. And I must say, I'm really pleased with the progress that's been made so far. For the next video in this series, I'm going to look at getting the meteor to move backwards and forwards across the screen, as well as getting collision detection working on the spaceship. Again, I'll be looking to do all of this in AMAL. So there are some areas that I think are going to be a bit of a challenge that I probably won't be able to do in AMAL, and that's have AMAL detect when the ship reaches the top of the screen and increment the score and reset its position back down to the bottom. I'm not 100% sure how to do that yet, how to get AMOS and AMAL talking to each other in order to facilitate that functionality within the game. But that will be a challenge for the next video. And on that note, please feel free to leave any comments or suggestions down below if you think or you know of a way that that can happen, or you've done this kind of thing before yourself, or you just have any ideas or thoughts on the process generally. Thank you. Don't forget the source code for this program as it stands currently and the graphics ABK file will be available to download for free from my website. There'll be a link down below for that. If you enjoyed this video, don't forget to give it a like, subscribe to my channel if you haven't already done so, leave a comment. All these things help this channel to grow. Thank you to my existing subscribers and supporters for your support. It is very much appreciated. So that's pretty much it. Thanks once again. Looking forward to seeing you on the next video where we'll advance this project a little bit further. But until then, stay safe and whatever you do, keep it retro. If you enjoyed this video, here's some others which you may find interesting.